Today, we're talking about a story about FemmFlo. FemmFlo is a femtech startup led by Tal Cook. Tal unfortunately cannot be here today, so I'm stepping in to share their journey. And I hope you can all hear me correctly. People at the physical location here, please put on your headphones. This is Tal. She is the real star of today's story. She's a force in women's health tech. She has bootstrapped FemmFlo to a full MVP with beta users, lab integrations, and partnerships. She has spoken to over 10,000 women in health and technology. She's a fierce visionary leader and someone you should definitely connect with. This is her LinkedIn QR code, so please follow and connect with her on LinkedIn. Think of me as a stand-in for Tal and the narrator of how AWS's technology helps take Tal's idea and turn it into the first LLM-powered platform for hormonal tracking, diagnostics, mental health, and personal care, all in 8 weeks. Before I tell you my story as a FemmFlo user, I want you to hear from Tal herself. She recorded this short introduction just for you.
Hi everyone, I'm Tal, co-founder and CEO of FemmFlo, the first LLM-powered platform to unite hormonal tracking, diagnostics, mental health, and personalized care in one system. Women's health has a massive data gap, and millions wait over 7 years for a diagnosis, navigating fragmented information and inconsistent advice. We've built FemmFlo to close that gap with an AI-driven approach that connects real-world health data to culturally relevant care plans, all running securely and at scale on AWS. Today, Meralda from Melio AI will show you exactly how we made that possible in just 8 weeks.
Thanks, Tal and AWS, for allowing me to share this beautiful journey with the audience today. For the next 30 minutes, I'll take you through why FemmFlo exists and what they deliver. Then I'll hand over to Ruan to show you how we built the AI MVP in 8 weeks and a technical deep dive, covering some AWS services and engineering trade-offs that made all of this possible. And finally, we'll hear from Tal again on what's next, and hopefully you can come find us later if you have any questions. And I know, 8 weeks sounds like an impossible timeline for building AI in healthcare systems. But what we did today was actually to allow and deploy the AI MVP for real users with real data to interact with Gabby, the AI. And if you want to remember just one thing from today's talk, remember this. Building AI in healthcare doesn't have to take years or millions, not if you have the right partner and the right platform in place. My name is Meralda, and I'm the co-founder and CEO of Melio AI. We work with companies to design, build, and deploy AI solutions since 2019, and we often work in industries that when the stakes are really high, like enterprise finance and healthcare. The truth is, I love what I do, but subjectively, I also think I have one of the toughest jobs in the world, being a founder and CEO. I used to be able to work for long hours, focus, juggle a million different things, but for the past 2 years, I have started to feel more fatigued and more anxious. And the tech industry's go-to advice is always, it's burnout. Just disconnect, go hiking, go find a hobby, and you will be fine. So I did. I got an emotional support animal, a Princess Curry. I go on monthly retreats in the mountains with my emotional support animal. And I become a fitness fanatic and also got a therapist. But I still feel tired all the time. And at some point, you start realizing, is everyone just gaslighting me? Or it's actually not my willpower that's broken, it's my body. It's my body that needed to be fixed. And that is the problem that Tal has set out to fix with FemmFlo. Turns out, I'm not alone. 70% of the women in public health wait for 7 years to get an accurate hormonal-related diagnosis. That is 7 years of uncertainty, symptoms, and no targeted plan. 30% of women report symptoms like fatigue, pain, and mood changes without effective tracking or care. And most importantly, 82% of women say that they will pay for personalized hormonal diagnostics and support. And the most crazy statistic is actually an average woman spends $18,000 over her lifetime of out-of-pocket care just chasing answers. This isn't about convenience. Delayed diagnostics impact careers, families, and quality of life. To really tackle this problem, FemmFlo didn't want to just focus on one piece of the puzzle. They built a 6-pillar framework to look at your health as a whole person. It starts with hormonal health. It's a lab-driven hormone mapping to get to accurate diagnosis. But hormones don't exist in isolation. With mental health is integrated with mood tracking, virtual care for psychological performance. Lifestyle is another big factor. Diet, exercise, and sleep recommendations are all tailored to the user's hormone cycle, and it's not just a generic piece of advice of disconnect. Then we look at things like work stress, relationships, and environmental factors because we know these social determinants can influence health outcomes just as much as biology. To make all of this possible, access and equity are baked in from the start so that underserved women are not left out trying to decode medical jargon and trying to get access to expensive healthcare. And finally, everything is tied together with a continuous monitoring where the AI feedback loops adapts the care plan in real time when the new pieces of data comes in. This is a very big vision, but the team at FemmFlo made a really good decision in the beginning of their journey because they understood one thing. As a small team, they know that speed has to be the superpower of their competitive advantage against the incumbents. So FemmFlo went AI first and put Gabby, their AI, at the center. It is not an add-on, but as the core. This choice meant that we can structure the data once and reuse it everywhere. AWS make all of this practical by having a single managed backbone. Ingestion, storage, retrieval, model inference, and even testing UIs and mobile apps are all powered by AWS so that it shares the same security and operating model. The payoff isn't just fast deployments, it's fast iteration. New data sources attached to the retrieval layer, the science officer from FemmFlo can validate the results, and we can promote all of those updates to the app within days. That's the difference between building a once-off POC and something that you can actually scale and grow as you grow your company. This is a $12 billion market of women with hormone and mental health needs. FemmFlo is starting with an $800 million launch market that is underserved, ready to engage, and where the culture fit is strong. Every step in the market generates a local health data that is needed to scale globally. And the sooner we start, the sooner the data begins to work to close the gap in women's health. We've talked about why FemmFlo exists and the problem it's tackling. Now let's zoom into what FemmFlo actually delivers and how AWS helps to achieve that. Let's first start with a typical user journey. It starts with an AI mapping her hormonal and mental health in one place with a one complete view. Based on her unique profile, she receives lifestyle guidance and a set of targeted lab tests. This is based on her symptoms, history, and local realities. So it's not a spray and pray approach of a very long list of tests to do and just-in-case screenings. When the results come in, they're turned into a personalized care plan. This might mean if your ferritin level is low, then we would recommend an iron-rich diet. Or if you are struggling with cortisol levels, then gentle recovery strategies is added to your plan. Or if your testosterone level is shifting during your cycle, then we can adjust your gym and exercise plan to make it more realistic. The goal is to translate all of these biomarkers into everyday action that is relevant and doable. From there, the FemmFlo app can become the daily partner of the users, tracking symptoms and lifestyle habits. Over time, then the system can pick up these early changes and help her to take actions before the symptoms escalate. And while today the focus is on individual users, the same model can be designed and scaled to B2B and public sector settings, like insurers, employers, and public health programs. In fact, the platform is built so that these larger deployments can be rolled out effectively. We've talked about the user journey. Now let's break it down to what truly makes FemmFlo stand out and how AWS services made all of this possible. First, it is every engineer's nightmare: integration. Most existing solutions focus on just one piece of the puzzle, like cycle tracking or mental health, without linking the dots. And FemmFlo connects hormones, labs, and mental health, and a bunch of other things into one system. At the core sits the Bedrock agent, orchestrating onboarding, check-ins, daily check-ins, and the lab results, while the API gateway makes it simple to connect everything back into the app. Second is localization. Generic and often Western-centric datasets can offer advice that is not practical for underrepresented women. FemmFlo uses localized data and user-specific data so that the recommendations fit their local realities. That means if you're in Nairobi, you're not going to get a more salmon recommendation into your diet because salmon can cost a day's wage. You will get an equally effective option that is affordable and available in your local market. So with S3, DynamoDB, OpenSearch, and lots of other databases technologies, AWS can give us a flexible storage option to handle diverse health data, letting Bedrock personalize outputs for each user's context. And the third is rapid rollout. Speed is everything in the race of AI. Other solutions can take months to stand up, but FemmFlo was designed to be modular and API-driven so that it can integrate in the larger settings a lot more faster. AWS managed services can help and handle the undifferentiated heavy lifting like IAM and some security aspects so that the team can focus on launching the MVP very quickly while still lay a very solid foundation for the future integration. And finally, it's cost. Traditional licensing can come with very expensive upfront licensing fees. FemmFlo uses a pay-as-you-grow model so that it is sustainable and even with low resource settings for their targeted market of underrepresented women. AWS make all of this possible with the serverless stack. Lambda, ECS Fargate, API Gateway, all of these are designed to keep the infrastructure cost low. Plus, for any of you who don't know, AWS are giving really amazing POC funding credits as well as cash to allow the team to focus on what matters, which is building the differentiator technology that really sets them apart. So across integration, localization, rapid rollout, and cost, FemmFlo can set itself apart, and AWS provided the backbone that made all of these differentiators possible. Now, let's look at how all of this tie in together from a user's perspective. The first step is to onboard onto the app, which is designed to capture the whole person and not just the cycle. We capture some basic information so that we can differentiate the advice given to women in Cape Town, Nairobi, or Laos. We also integrate critical health factors upfront, like contraceptive use, mental health history, neurodivergent conditions. These inputs usually aren't considered together, but together they shape how symptoms appear and how the care plans should respond. By grounding the app in these lived realities from the start, we can make our recommendations a lot more accurate and culturally relevant. And even small design touches, like allowing the user to select their Gabby avatar, can really help make the experience feel more personal and approachable. With the onboarding complete, she can start chatting with Gabby, and Gabby can start mapping her hormones and mental well-being into one integrated view. Once she is onboarded, she is encouraged to check in with her body daily. It is simple and optional, but even these really quick reflections on pain, mood, or energy can start to build a really powerful picture of her health over time. The check-ins beyond just mood or cramp. Jane can log pain, mental health, lifestyle factors, and changes in her cycle. It's broad enough to capture her lived experience, but it's also light enough that it can be done under a minute, because no one wants to do that over and over again, right? These touch points cover the full spectrum of health, from physical symptoms to stress, sleep, exercise. This large variety means that Gabby doesn't just see the period, she also sees the context around it. Each of these check-ins are saved and added to the user's profile. Over time, they don't just explain what is happening now, it also looks at the history and track changes so that we can help anticipate what is coming next. That's how the systems might be able to pick up early signals and adapt her plan in real time. And at any point, Jane can also chat with Gabby. Gabby is, instead of digging through graphs or long reports or lots of medical jargons of ranges and numbers, she can just ask questions in simple natural language, like, what phase of the cycle am I in? Or how do I manage my PMS symptoms? Gabby responds instantly, combining the data she logged with the clinical guidelines that is approved by the science officer. This gives her simple, actionable insights. It feels conversational, but behind the scenes, it's also powered by structured health data. Everything you have seen so far is grounded with real clinical partnerships. It's one thing to log symptoms, but it's another to connect these experiences with objective biomarkers. By working with labs and scientific partners, we ensure that the data isn't just personal, it's also clinically robust, and this is how FemmFlo is designed to bridge the gap between everyday health tracking and true medical-grade insights. You might be wondering, isn't this all a little bit too scary? What if Gabby hallucinates? Or what if Gabby gives the wrong advice? Who's going to be held accountable? That's why we didn't just throw AI into the production. We built a controlled testing environment where every answer is stress tested. Here you'll see the Gabby Open Web UI testing suite. This is FemmFlo's test workspace, where the science officer can validate Gabby's response before anything goes into the app. It allows us to run rapid tests, tweak prompts and guardrails, and check that every answer actually lines up with users' input data and the clinical guideline. Here is where the user can upload their epicenter hormonal panel so that it is added into their profile. Here, Gabby reads the long report and translates that into something that is easily stored in the database so that the AI can read it, and it's also passed on to other downstream systems. Gabby can read these numbers, store them under the user profile. It is very secure, and there's no crosstalk between the different users because these are very sensitive medical data. Then Gabby can explain these long and complicated reports in simple, plain language. There's no PDF full of ranges or numbers. It's just a simple summary of what is high, what is low, why does it matter for your health, and how do you manage it. You will see practical next steps such as sleep and stress routine if cortisol level is low, nutritional ideas if your ferritin is borderline, exercise patterns that support your hormonal balance, and if the user has any follow-up questions, she can also just ask Gabby, and Gabby can adapt in real time. This makes it really safe to iterate. The team can A/B test prompts, compare outputs, and document changes, then promote the exact same logic onto the mobile app for the users. All of this runs on AWS services, so the path from being tested to being deployed is very clean and auditable and safe for this heavily regulated industry. So it's very simple on the surface, but underneath it is a controlled workflow where the lab data comes in, The guideline is retrieved, the user context is then applied, answers checked by the science officer, and only then it can be shipped to the app. Now I will hand over to Rohan for a deep dive in how the MVP can be built in 8 weeks.
Thanks, Merla. Cool. Hey, everyone. I'm Rohan. I'm a data scientist at Melio, and over the past couple years, I've helped to design and deploy some of these agentic RAG chatbots with good success. So let me take you through sort of our recipe that we usually follow for doing these kinds of things. So a lot of the clients are worried about the time and capital investment required for some of these projects. But over the last couple of years, we've came up with this this winning formula that's like an 8-week program or like process for building some of these POCs, and it follows this rough framework. So we start off with a discovery phase. Sorry, the slide's not moving. So it's a 2-week discovery phase where the slide's not moving. I don't know if this clicker's not working. Oh, there we go. Okay, so we first of all start with setting out a clear definition of success, so we know what we're aiming at before we start building. And then we also identify some of the main integration points where our system will fit together with a larger system or needs to interact with humans or users. Then we do some data cleaning, and we confirm some of the assumptions up front with some of the subject matter experts, so we make sure we don't miss any of the main requirements. And then in the next phase, which lasts about 4 weeks, we start setting up this end-to-end process where we create an evaluation data set. So we make sure we cover all the edge cases, and we work together with the subject matter experts to create like a set of questions and expected answers for this. And then we also, as part of this evaluation framework, define clear success metrics that we can make sure we hit, so we don't go in the wrong direction, or every time we make a change to the solution, we can reevaluate it and make sure we're not far off course and moving the right needles in the right directions. So then after that, we start building, usually with the simplest architecture to start with, because there's also no reason to over-engineer anything before you even know what's going to be best for the solution. And then in the next 4 weeks, we iterate on this like minimum base that we've set up. So we work together with the subject matter experts and make sure we optimize the performance based on those key metrics that we set in the previous step. Then we also make sure we set up our monitoring and observability correctly, so we can see how the different components of our system interact with each other as the system is being used. And we also, this helps us to set up like alarms and notifications, so that we can know if any like failures or bugs occur up front, so we can sleep better at night. Then we do some cost estimates, and then we move into the last 2 weeks, where we make sure we tidy up all the integration points, make sure all the components are working together nicely, and we set up an operating handbook so that whoever the maintainers end up being for the system know what process to follow when something goes wrong. We then also do some red team testing, where we basically do some adversarial questions to the system and make sure our system responds appropriately and it can't be misused. And then we train any users that will use the system so that they actually know how to use it when it's out there deployed. So that's kind of the process we follow in general. So, but now let me take you. Before that, we usually do this for around $10,000 with a team of 4 people. So a product owner, AI engineer, cloud engineer, and a software engineer. But there's some nice funding opportunities from AWS as well that can help supplement the cost. So that's basically our recipe that we follow. And now let me take you into like a deeper dive for this project specifically, what we followed. So this is like a high-level architecture diagram with that shows how all the components interact with each other. And we'll go through this slowly right now. I know there's a lot going on, but I want to focus your attention onto two main components. So firstly, on the user interface side. This is obviously what the users interface with and what they see, and then that interacts with the agent in the background. So as you saw in the demo earlier, we used a piece of software called OpenWebUI, and this gives you a nice ChatGPT-like feel where you can type in your chats, you can see your conversation history, upload files, etc. So that comes out of the box with a nice user separation feature, as well as things like managing your chat history and things like that. So we deployed this on AWS using ECS Fargate, and we allowed some of that chat history and user separation features that it comes with by using two services from AWS, namely Elastic File Storage for keeping track of the things that were uploaded, as well as RDS, which actually keeps track of the different historical conversations. Cool, so that's the user interface side. And now that interfaced with the agent through an API, which we set up with API Gateway, and that allowed us to also set different API keys as an extra level of security, and also configure things like rate limits and throttling so that it's not abused. So the API communicated with what we called an interface lambda, the agent interface lambda, which was sort of one of the central compute units that orchestrated a lot of this. And that had a couple of responsibilities, including, if you look at the icon on top there, grabbing the user's onboarding data from DynamoDB. And this was done so that the agent could have context and know kind of who it's speaking to and their like medical background, etc. Then it also interfaced on the bottom. You can see LangFuse there. This is the software that we used for monitoring and observability. And this was quite useful to set up the traces and things, so you could see like the question that was asked to the agent, and then how the agent was reasoned about maybe what tools it was going to use and things like that to sort of create the final answer. And that was also very useful in evaluating the system, when you could dig through like the step-by-step how the system actually got to the final answer. So that interface lambda actually invoked the Bedrock agent, which is AWS's managed service for agents, and this is where you set up the agent's like main objective, as well as defining things like what tools it has access to, and with some prompt configurations you can say the tone and style it needs to respond in, etc. So we linked the agent with another service from Bedrock called Bedrock Guardrails, which is quite nice for making the agent just outright refuse to answer certain topics or inappropriate questions, just to make it more secure. So then it won't be an agent without tools. So the tool we gave it access to, in this case just one for the first iteration at least of this project, was the tool that grabbed lab results. And this was done using another Lambda function, and it grabbed some structured lab results from S3. And that gave the agent the context it needed to respond and answer some of the like lab questions. So yeah, the knowledge base in this use case was kind of a combination of the DynamoDB table and the S3 bucket that contained the onboarding and the lab onboarding data and the lab results. So you might ask, okay, how does this this is like the retrieval side only, but we need data in there first before the agent can answer these questions. And that's not indicated on this diagram, just to keep it simple. But basically what we did is, like, after the user uploaded like a PDF document of their lab results, we ran that through a structured extraction process, so we could store the structured results in a lab in S3, in the S3 bucket. So that's basically an overview of the architecture for how this thing works. Now let me dig a bit deeper into the knowledge base. So you might have noticed that we didn't use a vector store in this case, and it wasn't required because most of the data that we had to retrieve was quite small, and it was already structured, and it's not like we needed to locate a specific subsection of the piece that we needed to augment the context. We actually had to grab the whole piece. So no vector store was used in this case, and it, I guess, kept things quite simple. So one thing to note as well is that the onboarding data that was retrieved from the DynamoDB table was retrieved sort of early on in the flow through that interface lambda, because it was retrieved every time for a new conversation, so the agent could have enough context to know who it's speaking to and address the person correctly. On the other hand, the structured lab results was accessed through that tool, so the agent had an option to retrieve that, but it didn't always have to do that, because some questions don't require that. And then besides that part of the knowledge base, for the rest of the questions we relied on the baked-in knowledge inside the LLM, at least for the initial version, and we prompted it to respond with the correct tone and level of detail, and that seemed to work sufficiently well. On the evaluation side, one of the things we had to look at was the answer quality, and for that we had a standard set of questions that spanned different categories, like general mental and feminine health questions. We also had a category for hormones and deficiencies, which could be answered using the lab results that were retrieved. And we also had a section like specific to the user's profile that could be answered using the onboarding questions for a specific user. And then lastly, we had that set of inappropriate adversarial questions, so that we can do the red team testing and make sure our system responded appropriately to inappropriate questions. So this was evaluated through a mixture of both human and automated evaluation. So for the human side, basically a human just looked at the responses to some of the questions. And on the automated side, we had another LLM that actually inspected the question, the answer, what got retrieved from the knowledge base, etc., to get to some of the evaluation metrics. And in addition to that, we also looked at some general operational metrics like response latency and conversation cost. So using the results from that evaluation, we could actually guide our decisions and decide where to optimize, where the bottlenecks was, etc. So one of the things we needed to do was select the best LLM for this case. And for this, we had a couple of main competing objectives. So firstly, we had to have enough baked-in knowledge in the LLM to answer some of these like more nuanced questions that didn't rely on what got retrieved from the knowledge base. So that objective made us prefer some of the more larger models. But on the other hand, we also wanted low response latency and low cost, which kind of nudged us to choose some of the smaller models. So in the end, we ran through our evaluation framework using a couple of different models, and we went with the smallest one that satisfied all of our criteria, which at the time of development was Claude 3.5 Sonnet. Although it'd be interesting to rerun it again. Maybe there's like a new, better model. Always new, better models coming out. And that's basically it for the deep dive on the technical side. Let me now hand over to Virtual Tal again to explain some of FemmFlo's future journey and how you can join them.
Everyone, thank you so much for joining us. Our app MVP launches at the end of September, and we're raising $75,000 via a SAFE to scale in South Africa and Kenya, expand lab and pharmacy partnerships, and begin early B2B pilots. We're also seeking connections to labs in Kenya and Nigeria, insurers, wellness or pharma leads. Please scan the QR code on the screen to visit our investor and collaboration page, or connect with me directly on LinkedIn. I'd really love to continue the conversation and explore how we can transform women's health together. Before we close here today, I'd love to open the floor for your questions, whether it's about our AI technology, our partnerships, or how FemmFlo could work in your context. This is a chance to explore ideas together, so please feel free to ask.
Yeah, thank you so much. I think we can take any questions if you have.
I don't think we're allowed to take questions.
Oh.
Because we'll be like chilling on the side. And if you have questions, you can come find us. Thank you so much.
Thank you.